Good morning. It's August 8th, and this is your daily brief in science. Here's everything you need to know. NASA's Hubble Space Telescope has made a significant breakthrough by capturing the clearest image yet of interstellar comet 3-1/Atlas. This image reveals a teardrop-shaped dust cocoon surrounding its icy nucleus, located an impressive 277 million miles from Earth. 3-Atlas is traveling at a remarkable speed of 130,000 miles per hour and will pass closer to Mars than to Earth, posing no threat to our planet. The size of the comet's nucleus is estimated to range between 1,000 feet and 3.5 miles in diameter, although it cannot be directly observed. A research paper detailing these findings will be published in the Astrophysical Journal Letters, with current access available on ArcGIV. Multiple telescopes, including the James Webb Space Telescope, are currently studying the chemical composition of 3-Atlas, and its visibility is expected to last until September 2025. In addition, the newly operational Vera C. Rubin Observatory is projected to observe between 5 to 50 more interstellar objects during its decade-long survey, which will enhance our understanding of such celestial phenomena. The European Space Agency is also preparing the Comet Interceptor mission, scheduled to launch in 2029, aimed at studying pristine comets and potentially intercepting interstellar objects. The Hubble images of 3-Atlas are publicly available for further study by researchers and enthusiasts alike. Hubble has been operational for over 30 years, continuing to contribute significantly to our understanding of the universe through international cooperation between NASA and the European Space Agency. The origins of 3-Atlas remain uncertain, with astronomers facing challenges in tracing its path, likening it to glimpsing a bullet for a brief moment. Research suggests that 3-Atlas could be over 7.6 billion years old, potentially making it the oldest comet ever observed, surpassing the solar system's age of 4.6 billion years. Discovered on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System, 3-Atlas is expected to remain visible until September 2025 before it passes too close to the Sun. Astronomers have made a groundbreaking discovery, potentially imaging a Saturn-Mass planet in the habitable zone of Alpha Centauri A using the James Webb Space Telescope. If confirmed, this planet would be the closest known exoplanet in the habitable zone of a Sun-like star, although it is important to note that as a gas giant, it would not support life as we know it. The research team, led by Charles Beichmann of NASA, has dedicated nearly a decade to this project, with initial concepts proposed back in 2017. The detection utilized JWST's Mid-Infrared Instrument, or MIRI, employing a coronagraphic mask to block out the light from Alpha Centauri A, thereby revealing a faint object located about 2 times the distance between the Earth and the Sun. Initial observations in August 2024 identified the candidate planet, referred to as S1. However, subsequent observations in February and April 2025 failed to confirm its presence, leading to skepticism regarding its existence. There is also a 52% chance that S1 could be associated with another candidate, C1, observed previously, complicating the analysis due to orbital dynamics. Future observations with JWST and NASA's upcoming Nancy Grace Roman Space Telescope, set to launch in 2027, are planned to further investigate the planet's existence and characteristics. While the planet itself may not be habitable, scientists speculate that its moons could potentially support life, similar to moons like Europa and Titan in our solar system. The candidate planet is estimated to have a temperature around 225 Kelvin, comparable to Saturn, allowing for interesting comparative analysis with gas giants. This discovery marks a shift in exoplanet search methodologies, showcasing the capabilities of direct imaging and planetary science. The findings were published on August 7, 2025, in 2 companion papers in the Astrophysical Journal Letters, detailing the challenges and significance of this discovery. Beichmann emphasized the importance of overcoming the challenges faced in observing such bright and close stars with the JWST. A recent study has unveiled a potential breakthrough in the treatment of food allergies. Researchers have found that the asthma medication zileuton can effectively prevent severe allergic reactions known as anaphylaxis in mice by blocking food allergens from entering the bloodstream. Following these promising results, plans are underway to initiate a clinical trial assessing zileuton's effectiveness in humans. This could provide a much-needed preventive option for individuals at risk of food allergies. Zileuton is already approved for use in the United States and is available on prescription in the UK. In the animal tests, it showed significant promise, nearly eliminating allergic reactions in the mice. The research identified a gene called DPEP1, which influences how allergens are absorbed in the gut, playing a crucial role in susceptibility to anaphylaxis. Additionally, 2 studies revealed a previously unknown pathway in the gut that may contribute to food allergy symptoms, with the DPEP1 gene regulating leukotrienes that trigger immune responses. This study suggests a paradigm shift in food allergy treatment, moving the focus from targeting immune responses to mechanisms of gut absorption. Dr. Stephanie Eisenbarth emphasized that this innovative approach could provide essential protection for individuals, especially in unpredictable settings like social gatherings or flights. The findings also provide insights into why some individuals test positive for food allergies without showing symptoms, opening new avenues for future research into food allergy development. Immunologist Adam Williams expressed optimism about the rapid advancements in allergy research, indicating that significant breakthroughs may be on the horizon. Currently, food allergies affect over 33 million people in the U.S., with existing treatments often limited in effectiveness and sometimes capable of triggering anaphylaxis themselves. Jorge Emiliano Gomez Medellin from the University of Chicago pointed out that while zileuton may help prevent allergen absorption, it does not address the long-term sensitivity to allergens. A groundbreaking study from Ludwig Cancer Research reveals a critical mechanism behind immune resistance in cancer therapy. Researchers have discovered that neutrophils, a type of white blood cell, in bone metastases, are reprogrammed into an immature state, undermining the effectiveness of treatments, particularly immunotherapy. The study, led by Taha Mergoob and Tao Shi, identifies the protein DKK1 as a key player in this process. Produced by bone metastases, DKK1 contributes to the functional immaturity of neutrophils, which in turn suppresses their ability to generate effective anti-tumor immune responses. Importantly, the research suggests that CHY3L3 and its gene expression profile may serve as biomarkers for identifying patients experiencing neutrophil-mediated immune suppression. This could pave the way for more personalized treatment strategies for cancer patients. Elevated levels of DKK1 were found in gastric cancer patients with bone metastases, highlighting the clinical relevance of these findings. Analysis of serum samples confirmed increased DKK1 levels in these patients, which could assist in treatment stratification. The study proposes novel therapeutic strategies aimed at targeting DKK1 and reprogramming neutrophils to enhance the effectiveness of existing immune checkpoint blockade therapies. In mouse models of triple-negative breast cancer with bone metastases, blocking DKK1 restored neutrophil function and boosted the anti-tumor activity of CD8-positive T cells, resulting in significant tumor regression. These findings indicate that DKK1 blockade could be a promising combination treatment for bone tumors, which currently have limited effective therapies. The research underscores the complex roles of neutrophils in cancer, noting that while immature forms are associated with poor prognosis, mature neutrophils can actually support anti-tumor responses. Furthermore, immature neutrophils produce CH13L3, which disrupts the activation of cytotoxic T cells essential for targeting and eliminating cancer cells. On August 7, 2025, Google DeepMind unveiled an updated version of the Perch AI model aimed at revolutionizing the way conservationists analyze bioacoustic data. This enhanced model significantly improves the analysis of environmental audio data, particularly focusing on endangered species such as Hawaiian honeycreepers and coral reefs. The new version of Perch boasts nearly double the training data of its predecessor, which allows for enhanced predictions for bird species and better adaptation to underwater environments. Notable advancements include improved underwater acoustic analysis and the capability to filter out anthropogenic noise, which increases the accuracy of species identification. AI-powered acoustic monitoring enables continuous data collection, which reduces stress on animal populations compared to traditional methods. Conservationists utilize microphones and underwater hydrophones to capture a wealth of animal vocalizations that were previously difficult to analyze. Perch decodes these sounds and detects endangered species in remote locations, potentially replacing or supplementing costly manual review processes. Organizations such as BirdLife Australia and the LOHE Bioacoustics Lab are already leveraging perch for significant discoveries, including the identification of a new population of the plains wanderer. The updated model is open-sourced and available on Kaggle, promoting broader adoption among conservation scientists and streamlining data processing. Beyond conservation, Perch 2.0 is anticipated to aid in understanding animal behavior and ecosystems through acoustic signals, with previous applications in monitoring rainforest species. Overall, the Perch initiative exemplifies how advancements in bioacoustics can greatly enhance conservation efforts and promote biodiversity. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.